So starting with the intermediate value theorem, where we have to have continuity on whatever interval we're talking about, and then it just says that for every value d between f of a and f of b are endpoints, there exists a c such that f of c equals d. So in layman's terms, this is that theorem that tells us if f is continuous and then we have two different values, f of 2 is 5, f of 12 is -2, then we are guaranteed every single y value in between. So we're guaranteed some f of c that equals 3, we're guaranteed an f of c that equals 1, an f of c that equals 0, an f of c that equals -1, and of course decimals as well, but everything in between -2 and 5, we're guaranteed those y values. For the mean value theorem, the function does have to be continuous and differentiable on that certain interval. There has to exist at least one value where the instantaneous slope is the same as the slope between the two endpoints. So if we had some function that's continuous and differentiable on 1 to 4, then whatever that slope is between 1 and 4, we are guaranteed some value where the instantaneous slope is the exact same slope. And then our last big theorem, Rolle's theorem, really piggybacks off of the mean value theorem. Still has to be continuous and differentiable, but also f of a has to equal f of b, so that means that the slope between them is 0. So we are guaranteed some c where f prime of c equals 0. So somewhere that instantaneous slope has to be 0. So for example, if we knew that f was continuous and differentiable on 1 to 4, and we knew f of 1 equaled f of 4, so it looks something like this, where f of 1 is the same as f of 4, then we know the slope between those two is 0, so there has to be some c value that has an instantaneous slope of 0. More or less, it has to have a min or a max somewhere. So our first example, they give us a function that is continuous and differentiable for this -2 to 1 interval, and then they give us a value -2, -5, and then 1, 4. So I went ahead and put them on a graph. We do have it being continuous and differentiable, so if we want to go ahead and connect those, it's not exactly what it would look like, but just gives us a pretty decent example. We're looking for what is false. So hopefully we end up with a lot of true statements here. So A asks, there exists a c in between our -2 and 1 such that f of c equals 0. So are we guaranteed a y value of 0? Definitely by the intermediate value theorem. That is true. For B, there exists a c on that interval that f prime of c equals 0. So in order to be guaranteed f prime of c equal to 0, that means that the slope between our -2 and 1 should be 0. So this does not seem like it's true. We'll come back to that one. C, there exists a c on our interval that f of c equals 3. Well, 3 is in between -5 and 4. So again, by the intermediate value theorem, we are guaranteed a y value of 3. For part D, we're guaranteed a c such that f prime of c equals 3. So for this one, I need to check my slope between -2 and 1 and see if that is guaranteed or not. So if I have my 4 minus -5 over 1 minus -2, I will have 9 over 3, which is 3. So because the slope between my endpoints is 3, I am guaranteed by the mean value theorem an instantaneous slope of 3. So somewhere that has to be happening. My last one, there's a c on our interval such that if f of c is greater than f of x for all x in the closed interval, -2 to 1. So this one actually is not talking about one of the big theorems. This is just something we talked about for absolute maxes and mins, that if we have these endpoints and then in between it is continuous, that means that we are guaranteed an absolute max and an absolute min. So there has to be one point that is the lowest of all of them, there has to be a point that is the highest of all of them. So this is true as well. So it was they were not guaranteed an instantaneous slope of 0. Our next example is more direct. It's asking us to find the value of c that satisfies the conclusion of the mean value theorem on f of x gives us a parabola here for the interval 2 to 5. So we have to be careful here that we're not only using the mean value theorem, but we're in the end looking for that value of c. So that means we're looking for what is that x value that gives us the same instantaneous slope as we have a slope over the interval 2 to 5. So to save some time, I went ahead and found f of 2 and f of 5 so that we can find the slope between those 2 points. So it looks like we're going to end up with 3/3, which is 16. So you get a slope of 16 between 2 and 5. So now we're not done. Now we're looking for where is the instantaneous slope, 16. So if we're talking instantaneous slope, I need to go ahead and find the derivative of f of x. So my f prime here is going to be equal to 6x minus 5, just using the power rule. We're trying to look for where that 6x minus 5 is equal to 16. And we will get that that happens when x is a 21/6, which can be reduced to 7/2. And we do have a 7/2. There we go. So our last example is very generalized, and it's a little bit different on the wording. So for this, we're talking about a function that's continuous, but for any point c in between a and b, which of the following is true? So it's not talking about there exists a c where this happens. It's saying for every single c in between a and b, this has to be true. Go ahead and pause the video, see if you can decide which one of these has to be true for every value of c in between a and b. So the wording of this problem makes a big difference in how we go about looking at these, because looking at a, it kind of seems like the mean value theorem, but it would be saying that for every single point c, the instantaneous slope is the same as the slope in between a and b, which is just not true. We also don't know that f of a has to equal f of b. We have no reason to say that. We have no reason to say f of c equals 0 because we don't know what the values for f of a and f of b are. They could both be above the x-axis or both be below the x-axis. Option D is telling us that the integral from a to b, so the area of this whole interval, would have to equal f of c. So this is just not founded at all, that the area would have to equal that y value. Doesn't make a lot of sense. And then our last option, hopefully this one works. For option E, it's telling us the limit as x approaches c would have to equal f of c. So remember that when we're finding limits, we would be plugging in c, and the only time that we plug in c and it works right away is when that function is continuous. So this is always going to be true for a continuous function.